So we just finished solving a polynomial inequality. We're now going to go to rational inequalities. The major difference here is that you must make sure you do not include any number in the interval notation that would make the denominator equal to 0. So the steps to solve a rational inequality are: 1, find an equivalent inequality with 0 on one side, write the related function with an equal sign, and then find the values of the variable for which the related rational function is not defined. In step 3, solve f of x equals 0. In step 4, with the numbers that you found in that step, those are my critical values, we're going to divide the x-axis into intervals and determine the sign of each interval. And in step 5, we're going to select the interval that makes the inequality satisfy. That makes the inequality true. So in example 3, we have the rational inequality x plus 1 divided by x minus 2 is greater than or equal to 3. So step 1 says to find an equivalent inequality where 0 is on one side. And that is x plus 1 over x minus 2 is equal to, or is, let's see, we're going to subtract 3. And that's greater than or equal to 0. And then what we're going to do to solve or find our critical numbers, we're going to set it equal to 0. And then we're going to look for values of x for which the related function is not defined or 0. So we can see that x can't equal to 2. So that's one of our critical numbers when we graph it. Now we're going to solve. And to solve it, we're going to multiply both sides of the equation by the LCD. And so the LCD is x minus 2. So x plus 1 over x minus 2, we're going to multiply that by x minus 2, minus 3 times x minus 2 equals 0 times x minus 2. And now we can cancel this out, and we have x plus 1 minus 3x plus 6 equals 0. X minus 3x is negative 2x plus 7 equals 0. 2x equals 7, so x is equal to 7/2. So now we have determined what the critical values are. We can write as a decimal, that's 3.5. And the first one was 2. And now we're going to plot these on a number line, putting in my critical values here. We're going to test points on the interval. A number that's smaller than 2, I'm just going to choose 0. A number big between 2 and 3.5, maybe 3, and we can use 4 over here. We're going to plug it into this equation. The sign we want is greater than or equal to. So I'm going to just jot that down over here. So f of 0 is 1 over negative 2 minus 3, which we know is going to be a negative number. I just realized I copied that down wrong. It's a greater than or equal to is what we're wanting. Okay. So the f of 0 is negative. We're going to test point f of 3 in my equation. So we have 3 plus 1 is 4 over 3 minus 2, which is 1. 4 minus 3 is equal to 1. So that's positive. And then the last one is 4. So f of 4 is 5 over 2 minus 3, which is 2.5 minus 3, which is going to be negative. Okay, and so we can see that the interval where this rational function is positive is going to be in the middle. And notice because of the equal sign, it's going to be closed. So our answer is from 2 to 3.5. Now, the 2 is a restriction from the first thing we did. Since that's restricted, we know that x can never be 2. So where it's closed everywhere else at 2, it's going to have to be open there. So we're modifying my answer from open at 2 to closed at 3.5.